My name is Carly, and today I'm here to talk about performance bottlenecks and how OpenTelemetry is not enough. So I'm going to explain what OpenTelemetry is for anyone who's new. I'm going to show an example of how you can instrument a sample Java application, and I'm going to ask the Java champions very nicely to not mock my Java code. We're also going to talk about real user monitoring of a JavaScript application, because based on my own prior experience, you tended to have a JavaScript front end sitting somewhere talking to a Java backend. So we're going to talk about instrumentation of basically an entire application. And I'm also going to explain what EDOT is, because I don't think anyone knows what EDOT is. But firstly, it'd be rude not to introduce myself a bit more formally. So my name is Carly Richmond, as it says up there. I'm a principal developer advocate, and as of a few months ago, I took over management responsibilities. Going all right. I've not destroyed anybody yet. I think. And I hang out in all sorts of places on the interwebs. So if you want to connect or come and speak to me afterwards, I don't bite. I promise I'm friendly. Please do come and say hi. But I'm here to talk about bottlenecks, which I had a lot of nightmares of when I used to work in banking. So before I became an advocate, I used to build applications for a tier one investment bank. And it was an absolute nightmare trying to figure out where bottlenecks were, where things were slowing down, why a particular queue was filling up, why everything was going to the dead letter queue, all these things that were absolutely terrifying. And because I also worked in a microservice ecosystem, disclaimer, we're not going to get into the microservice versus monolith debates. Let's save that for the drinks afterwards. I know you look so disappointed, Piotr. We're not going to get into that. But the fact of the matter is, we look after applications now that are exceptionally complicated. So one of the things that was really particularly difficult for me was I used to be the front-end engineer that would dabble in the Java services. And because users don't necessarily know exactly where a bottleneck is, or it's normally this particular component that's failing, you end up in a situation where all the issues that came to level 3 escalation came to me because it must be the UI because there's no data. And because of the complexity of these systems, all the associated services, the different sources of information, it wasn't always 100% my fault, I promise. So we need observability. So this is the definition I actually pulled off the OpenTelemetry site. Observability lets us understand a system without necessarily knowing all the nitty-gritty details of the individual pieces of code and attributes. So we don't need to know exactly what's going on in every single line of code and all the inner workings. The idea is it allows us to handle unknown unknowns, those situations that maybe we didn't plan were going to happen because as developers we're perpetual optimists, as Fred Brooks always put forward, or just sometimes something that we never even dreamed was going to happen. Because that ultimately, when you're in a situation where you're needing to rely on tracing to figure out where a bottleneck is, figure out why something is going wrong, you're sitting asking, why is this happening? And if you're me, potentially, why is it happening to me right now when I want to go out the door? For that, we need signals. Now, things have changed since I was a baby developer, where all I had was 5 days worth of logs to look at. We all know what logs are. Logs are those timestamp messages, potentially stack traces, potentially not very useful messages that we instrument and add into our code to try and explain what is potentially going on with it. But it's not the only type of signal that we can use, thankfully. We've also got metrics. So metrics are a measure, an indication of, the runtime state of a particular service or system. So maybe it's disk, maybe it's CPU, maybe it's throughput, or as you'll come to see with RUM, it might be something called Core Web Vitals. And then you've also got tracing. Tracing is basically the path of execution, not just through your program, but from connecting these individual services. And remember back to that big, scary microservices architecture I showed at the beginning? We can use tracing, if we're smart with it, to try and join the dots and see what's happening at which point within that particular ecosystem. So hopefully everyone can see this, but this is basically what we're going to cover today. We're going to talk about two things. We're going to talk about OpenTelemetry agents. You can use APM agents, so APM would be application performance monitoring. Agents, they tend to be very vendor specific, very tied to the implementation of wherever you're ingesting that information. we're going to use OpenTelemetry because that is an open standard. It's something that's very well established depending on the language ecosystem, which we'll touch on as well. And also it's something that Elastic, we are deeply and heavily involved into. So we always like to yell and sing praises about it. But I also want to join it in with front-end instrumentation, which I'm using a specific RUM agent for. I'll explain why I'm using a vendor-specific RUM agent when we get to that point. But irrespective of the situation, what we're going to do is we're going to be ingesting them into Elasticsearch. And the way we do that is through using the APM integration. So you have a small APM server running as part of your Elastic cluster, whatever it is, and that allows for the data to be propagated down to Elasticsearch, so those logs, metrics, and traces I was talking about, and then we can use Kibana to see what's going on and perform that troubleshooting to identify those bottlenecks. Now, clicker works good. So firstly, we talked about OpenTelemetry. This is the documentation for the Java OpenTelemetry SDK. Few things I want to note firstly. One, the status of it. So irrespective of which language, so I know we've got Java aficionados in here tonight, but does anyone use any other languages? You use Python, Kyle? So I think it's a mixed bag. Golang? Kotlin? I have no idea. I have no idea on the state of the OpenTelemetry for Kotlin. I'll be checking that afterwards. Any other languages? Yeah. I assume that's covered under JVM. Yeah. Cool. Interesting. I only tended to use Groovy as part of Gradle. Yeah. Yeah, that's it. That's true. I'm sure we'll get into debate on that later. Cool. Any other languages now? So each of these, it really depends, but it's important to check status and releases, particularly if you're wanting to instrument for production use. But thankfully in the Java ecosystem, we are very fortunate because everything is stable, nothing is currently under development, so we can happily use it in production, knowing it's well supported and maintained. There's also several repositories that we need to think about in the Java ecosystem. So we've got the main components for manual instrumentation in OpenTelemetry Java. You've got the docs, which is the examples. You've also got the instrumentation here, Java instrumentation. So this is basically the Java jar that can do with auto attach. There's the contribution libraries where, you know, things that don't necessarily correlate directly to OpenTelemetry that are still useful. So JMX metrics gathering would be a key indication. The semantic conventions and also the proto definitions as well. So to confuse things, Elastic have introduced their own distribution of OpenTelemetry called EDOT. So I said EDOT at the start. Here we go. Basically the way to think of EDOT, the way I like to think of EDOT is that the contributions that Elastic are making that take time to go through the OpenTelemetry space can indeed be used early through use of the EDOT agent. That's the way to think about it. So I'm going to now show a demo. We're going to pray to the demo gods, cross our fingers, our toes, all of that, and show how the automatic instrumentation works. So I have a sample application written in Java. All it is a super simple application written with Spring Boot. And I've got a single controller, okay? Nothing to write home about. Pretty sure people could write far more complicated things that are sitting in this room at the moment, but here we go. In order to do the automatic instrumentation, we need to do two things. We firstly need to set the appropriate environment variables and context for OpenTelemetry to pick these up. And that's what I've got here within my compose file for YAML. So you'll see the environment variables I'm defining are the OTel resource attributes. So these are optional additional attributes that I want to add on to all of the signals that I'm sending through. I'm sending through the service version and the deployment environment. Why are these important? Well, particularly if you're trying to figure out if a change has perhaps been dormant for a while and you're trying to figure out maybe if it's an issue that has appeared a few versions ago, or perhaps you're in a situation where you have different deployments. Maybe you're using Canary deployments and you want to compare what's going on between two. Having these attributes is always a useful thing. You've also got the service name, i.e. a unique identifier for this particular service. We need to be able to distinguish between these services within that microservices architecture, and that's exactly the option that we need to use. You also need to specify the OpenTelemetry endpoint that we're going to use. In this case, that's going to be your Elastic endpoint. I've got an example environment variable here. So you'll see that I'm going to point to the APM server specifically. Okay. The other thing is the headers. Now I've got a sample up here for an example. You all seem like lovely people, but I'm not going to give you the key to my Elasticsearch cluster. I'm sorry. You know exactly what I mean. Demos and keys, people, demos and keys. So what we do is specify the API key as part of the OTLP header, and that will give us the authorization which we're going to need, okay? Then I'm specifying the format in which I'm exporting traces, metrics, and logs. Now for Elastic, it is the OpenTelemetry protocol. If you look at the OpenTelemetry documentation, there's others depending on what you're sending, the type of signal. So there's a Prometheus format, for example, if you're sending to Prometheus. We're going to talk about inferred span shortly, so I'll keep that one secret for the moment. If you're in a situation like I was last week, trying to get this working, bashing your head off the desk and wondering what is actually going on, there is indeed a Java agent debug option that you can set to true, and that will add in the additional logging telemetry so that you can try and debug what's going on. Okay, cool. So that is all my environment variables. The other thing, since I'm using automatic instrumentation, I need to take care of is I need to make sure that I'm utilizing the Java agent option to attach the OpenTelemetry jar. If I was using the OpenTelemetry native SDK, I just download that jar from Maven. I'm using the EDOT one, which again, also downloaded from Maven. And what I do as part of my Docker file set is I copy this to the respective folder so it's accessible, and then I use the Java tool options in order to run the agent. Without changing any code, I have instrumented my Java application. What that's going to give me, if my demo has worked, I think the demo gods don't like us today, Kyle. All right, let's see. That's fine, because I'm pretty sure. I think I can just look for data that I pulled earlier. So if I look for the last 24 hours, I have some data from earlier on. Here we go. All right. So here is record store server Java. This is all the telemetry information I am sending using EDOT. So you'll see it's sending through latency and throughput metrics. It says I've got no failed transactions, but given this demo's fallen over, I'm probably going to go and have a look at that. But it has given me an error, which I didn't have before. I have an interrupt exception that looks to have been seen in the last day. So if I go into this, you'll see it was triggered. Oh, it was triggered last night when I was doing my trial run. That's good to know. And you'll see that I've pulled out the full error trace. So it's actually pulled out the appropriate stack trace and given that for me. You'll see I've also got metrics. So again, if I go back to the last 24 hours on this one, I know you've had metrics in the last 24 hours. Don't go faking now. That's why. It helps if you clear the exception type, right? There we go. Let's try this again. Woohoo! Metrics. It's about the little things sometimes, isn't it, people? Right, so you can see it's tracking CPU. I've got heap and non-heap memory usage. It's also got details of the appropriate pools, and I've got thread count stats as well. There we go. There we go. So you can see the average and the max are being captured in here. So that's metrics. Logs. Not very useful messages, but we are getting the live logs coming in from 6 p.m. earlier. And then in terms of transactions, if I go to this one, you will see that it's also pulled in from record store server Java, this particular additional internal operation. And you're probably thinking, but you did this with automatic instrumentation. How have you got that? And the answer is from inferred spans, this option here. So the next question you're going to ask me is, what are inferred spans? Inferred spans are one of these elastic specific contributions that are not yet available in OpenTelemetry that I was talking about earlier. And an inferred spans is basically going to allow you to recreate what's going on in terms of the underlying layers without having to add in custom instrumentation, which I'll show you how to do as well. It uses the popular async profiler under the covers. If you want to understand the detail, I recommend going to this piece here, where the agent engineers have actually talked about how it's working under the covers. It engages with the life cycle of spans events across any threads. And the reason it's able to do that is because it's using the OpenTelemetry context itself to do that. And it's also correlating the profiling data with the log of the span events. That's how it's basically reconstructing those spans by connecting those two sources of information together. Now, you might want to do manual instrumentation. There's two reasons you might want to do that. Either one, you want to have very fine-grained specific control over the initializations and don't want to utilize automatic instrumentation. If you want to make more work for yourself, that's fine. The alternative is you want to add in additional instrumentation, perhaps business events or other information that you want to see in your telemetry, and that's A-OK. So you need to make sure that you've updated with the corresponding dependencies. And from there, if you want to do the instrumentation yourself from scratch, this might be difficult to read, but what you'll basically see is I'm pulling in the service name. I'm setting the service name on all of the OTel signals using the resource attribute. Then the next thing I'm doing is I'm initializing the logger, specifying things like the protocol as OTLP, specifying the endpoint, adding in the appropriate headers, and setting the batch processor to be the OTLP GPRC log writer exporter. So it's basically using the builder pattern to manually create that provider instead of using the auto instrumentation. Same thing for traces, same thing for metrics, metering. And then what you'll see is I'm setting the global context of OpenTelemetry as the particular SDK using all of these providers that I've created, setting that SDK as my global OpenTelemetry settings, and then adding a shutdown hook so that it's going to close down. Right. But we want to know how to create our own spans. And for that, it's a wacky combination because you can still use EDOT, but you also utilize the OpenTelemetry API, that dependency there. So what you'll see within my application is I have created a bean where I'm basically getting the OpenTelemetry global context, okay? And then from there, inside my controller, you'll see I am initializing a tracer by getting the tracer from OpenTelemetry associated with the service name, which is that environment variable. So in this case, we're still utilizing automatic instrumentation. It's just that we now want to add our own custom spans on the top. And then in my service where I get all the records back, so it's just a simple GET request, I am on top of that tracer utilizing the span builder to create a custom span, setting the kind as server and starting it. You can also set attributes. So these might be, Elastic Common Schema formatted attributes relating to HTTP requests. So I've got the method, the URL, and a very optimistic response code sitting in here. And then when you go to actually capture the events using the span, you make sure that you make it the current span setting, the scope. And then I do whatever I want to do that's going to be captured within the span. Obviously, I'm going to catch any exceptions and record it on the span itself if that does happen. And then finally, I've got to tidy up after myself, make sure the span is closed, and you would end the span at that point. Now, with that, There we go. Okay. Now, if I go back to transactions, remember this custom one? So that's definitely coming through. But the other thing is it's actually attaching to that parent trace before. So you'll now see what's different compared to the one with the query attribute where no custom span has been added on. I am able to see the custom records custom one underneath and that original get all records call. Does that make sense so far? Sweet. Okay. So let's move on, shall we? Now, remember I talked about users before and talked about how you need to instrument your front end as well. The reason is that instrumenting your backend services is not going to catch everything that a user does for several reasons. One, they don't always use our applications in the way we expect. That's why I was able to build and fix code in the UI for 10 years, because they did all sorts of wacky things I never envisaged. But also because there might be legitimate errors that you are not going to catch if you're only instrumenting the backend services. For that, we need to crack out the RUM. I'm going to apologize, there's only beer and wine this evening for any rum drinkers, but I am not talking about the alcoholic beverage that, is commonly drunk around pirates or even my husband at home. I'm not talking about that. I am talking about that RUM agent. So, had to get a parent joke. Right. The state of UI telemetry is complicated because ideally I'd be giving you a story of OpenTelemetry has something that you can use and you can ingest it into Elastic and we can use OpenTelemetry for everything and it'll be fantastic and wonderful and dancing unicorns and all of that. I don't have that. I don't have that story because the current state of the SDK for JavaScript is that it does indeed run for Node.js and in the browser, and you can capture tracing with it. You can capture metrics too. Logs, currently under development, so I wouldn't recommend capturing your logs for production use. Consider using a logger and maybe a framework like Winston in order to export that out into Elastic, and there's steps in the documentation of how to do that with Winston, Pinot, and one more. But it's this particular one here that I want to call your attention to. Client instrumentation for the browser is experimental and mostly unspecified. If you are interested in helping out, get in touch with the client instrumentation SIG. So if you are interested in helping out, get in touch with the client instrumentation SIG. But that doesn't help you right now. So now we need to crack out the RUM. But before we do, I need to give you a warning. Because like with adding any JavaScript agent to a JavaScript running application, we need to be mindful about bundle size, because that can impact the loading time and experience for users. By default, RUM agent logs all the debug messages to the browser console. They're useful for development, but they make the bundle size large. So there's an example underneath here for Webpack, which would be one of the more common bundlers within the JavaScript ecosystem. And what you need to do is basically make sure that you have an optimized build. This is not just for RUM, this is generally for, general best practice within JavaScript ecosystem. Please have an optimized build. Please also consider minifying your code. These shouldn't be obvious. Right, so why RUM? Well, RUM gives us access to the tracing, which we'll see in a minute. And it gives us metrics, not just metrics in terms of CPU or those kind of useful memory footprints. It gives us access to things called Core Web Vitals. So quick show of hands, who has heard of Core Web Vitals? Nobody. I've got a blank slate. This is very exciting, and no one can question if this is correct or not. Of course, it's going to be correct. Core Web Vitals are a set of metrics, as you probably guessed, that are used to give an indication, we'll say an indication, of the performance of a website from a user perspective. As you probably guessed, initially created by Google. I believe the initial version of the metrics was released in May of 2020, if I remember right. And they are very useful for giving a rough indication. Traditionally, they're normally captured using tools such as Google Lighthouse, which you can use to run reports either within the browser. So if anyone wants to get really excited about go home and run a report for Core Web Vitals on a website, just open the DevTools in Chrome. There's a Lighthouse tab. You can run the report there and you'll get synthetic values that basically showcase the vital stats for that particular site. You can also run it in all sorts of other places. For example, anyone using Netlify, you have a plugin that allows you to assess the values for your site. Anyone who's interested in SEO, which is probably not in the room this evening, also are interested in Core Web Vitals because they're included in the search rankings criteria for Google as of June 2021. And they change as well with the most recent versions announced in March of this year. In terms of measures, the first one is largest contentful paint. In terms of what this is for, it's that idea of initial experience. So we've all had that situation where we go to a website and it just seems to be not doing anything to start with. It's just blank and we're waiting ages for it. This is LCP in action. It's the render time and the largest image or text block visible within the viewport. So it's that initial time for something to load. And ideally, you want this to be under 2.5 seconds for a website to be considered performant. The second one I'm not going to talk about is first input delay because it is now deprecated. This was basically previously the only measure really for responsiveness, i.e. responsiveness to user input. But the problem with it is that word first, because it was the time taken from when a user would input their first action, such as a click or a text entry, and it didn't do anything after that. And as we all know, we do more than just one click on a website. We tend to be interacting with multiple flows, multiple buttons. So as of March this year, the new measure came out, which is interaction to next paint. So if anyone's seeing interaction to next paint in a tool or they're using FID, you'll be able to tell if it's been updated or not, which is kind of handy. The longest duration of latency of all the clicks, taps, and keyboard interactions within the lifespan of the page. And ideally, it's going to be under 200 milliseconds. Otherwise, you're going to have people potentially trying to retry it, thinking that the application is not working, or if you're impatient like me, potentially doing a bit of key mashing. And then the third one is what we call cumulative layout shift, which, to be perfectly honest, I didn't understand. Until that time, I was basically trying to connect to my son's Bluetooth headphones and ended up connecting to the wrong device because they switched in order before I got the chance to click. When the page moves, there's a chance of user error where they're going to end up clicking the wrong thing. And this isn't normally obvious until you've done something really silly, like a few months ago when I accidentally ordered something to my sister's house instead of my home. True story. Because I realized I had clicked the button and couldn't go back and undo it. So what it does is CLS is calculated across the entire lifespan of the page, and it looks at all those layout shifts, the degree at which the page is changing, and then picks the largest burst. And ideally, it should be under 0.1 to be considered a site that, you know, I'm going to not accidentally do the wrong thing on. So we need to know with RUM how to instrument our applications. Partially depends, to be perfectly honest, on what SPA framework you're using. And it also partially depends on whether you're able to change the JavaScript or not. And I know that sounds like a weird thing to say, but I've had situations like that. So if you cannot change your JavaScript, perhaps you are using a super old implementation. Maybe you're using a really old framework. I'm thinking back to my banking days again, and you don't want to change the application. You don't want to change the code. You can utilize the script tag within HTML itself, specifying the path to the particular version of the RUM agent, and then you can initialize it. There's also an asynchronous pattern. You kind of get the idea. For modern applications, you will want to utilize init. So init, as you'll see, it's an npm install of the Elastic APM RUM client. Hopefully everybody can see this okay. And you'll see that I'm initializing it, specifying a service name, same as OpenTelemetry before that we have with Java. Distributed tracing origins. By default, the RUM agent runs on a single origin policy. And in order to make sure that we kind of connect these front-end traces that we're going to capture with the back-end traces of that Java application that we showed earlier, we need to have the appropriate trace parent header added to the HTTP request that's going to be being passed back. And that's effectively what distributed tracing origins is going to do for us. It's going to basically say, trace parent, this particular host, and I'm going to be able to trace everything back. Server URL, again, APM server. The optional version and environment. And again, If you're wondering what's going on, maybe it's not sending you data, you can use the log level debug option and it will spew all the events out to the console so you can see what's going on. Where it also gets complicated though is when we use SPAs. So I'm meaning by SPAs those frameworks that we're commonly using. So React, Angular, Vue. And with the agent for Elastic specifically, you have extensions that you have to install alongside. So this is the Angular example. With APM RUM React, I am importing the APM roots component, and then I actually wrap it. Where's my roots gone? There we go. I wrap my roots for React Router DOM around that element, and that will give me the telemetry I need for the routing. This is for version 6. If you're using an older version of React Router DOM, is anyone a React developer? No. So you know the pain of trying to upgrade React Router DOM. It's not nice, is it? Yeah. I'm sorry. Well done. Yeah, so you get my pain then. React Router DOM changes very significantly between majors. So you need to check the documentation and make sure you're using the appropriate version implementation, but this is how you would do it for version 6. Oh, yeah, your number of roots as well will be crazy, right?
Yeah, I thought the roots also are quite generic.
Oh, I have so many questions. So the alternative is Angular. I have to give a nod out because this was one of the first SPA frameworks that I used. The implementation is very similar, but I call this out specifically because of the nature of Angular error handling logic. You need to basically substitute the error handler with the APM error handler from APM RUM Angular. So that's just a warning for that one as well. But again, the initialization is the same. So when you do that, you'll have the RUM agent running. What telemetry is it going to give you? Well, let's dive in and find out, shall we? So if I go into services, you'll see it's picked up my Angular UI. And you'll see that I'm picking up the latency, the throughput. I'm picking up click events, which I wouldn't have if I was using the OpenTelemetry SDK. And then under records, if I scroll down here, you will see it's picked up Angular, it's picked up the Java component as well. And underneath my records call, I can see the parsing of particular documents. And see right here, there's that custom span. There's that records query span. So it's managed to connect all of this together into the same pair, into the same trace because of the passage of those particular headers. But it also gives us, through the user experience dashboard, the metrics that we were looking for. It gives us core web vitals, gives us page load stats, so I can see that this page is taking 10 seconds to load. Let's investigate in a minute. But I can see my core web vitals, page mode distribution, page views. For some reason, yep, been using it. It says I've been using it in Germany. That's not right. Interesting. Need to find that out later. And then I get agent breakdown, so I can actually see things like the particular browser that's being used. As a person that had to deal with Internet Explorer issues a few years ago, this is a very useful component. And you can see also the operating system because it's capturing the user agent diagnostic information as well. Yeah, it's got the same capabilities. Exactly, very similar, very true. Yes. But we want to know why this is taking 10 seconds. And this goes back to that transaction. Sorry?
You also wrap it in your bottlenecks.
Yeah, so it's doing the same thing basically. So it's kind of their RUM agent as well, but it's doing the same thing. And any other RUM agent you're doing, I think RUM Vision works the same as well, but you basically wrap the roots in the exact same way. Cool. So yeah, so of this 10-second call, what I can see is that actually it's that individual query that's taking 10 seconds, but actually my get record by query is only taking 9 milliseconds. So clearly something's wrong in here and I don't think anybody noticed. But if I go into my controller, this is probably not going to help me, is it? That's the way, that's the way. Please don't put that in your code. Toy apps are fine, but I think people would be very unhappy if I put sleeps like that in my production code. It's a 10-second thread wait. So we've talked about Elastic tonight. We've talked about RUM, not the drink, real user monitoring agents, talked about OpenTelemetry, and I've also introduced EDOT Java. Now, if anyone is using anything Elastic at all, it could be the APM agents because you've come off being inspired and want to use OpenTelemetry and RUM and all the rest of it. It might be you're using it for a search use case. We always love hearing about it. So we run a contributor program every year. You got a chance to win cool prizes. Feel free to scan or come and speak to myself if you have any questions. But with that, it has been a pleasure. If you have any questions, come and ask. I don't bite, and feel free to help yourself with more pizza or drinks. Thank you very much.